Okay, seventh grade. We are going to be looking at section 10.6 today. As you can see, the title of the section, we have special right triangles. Um, in my opinion, all triangles are great. These are special right triangles. You can see by the name that they give them, they're going to name them by the angles. And that's going to help us determine some sides without knowing as much as we would have in other cases. Okay. So the first thing we're going to notice here with this 45, 45, 90 triangle, it's not a real creative name. Okay. It's just based off the names of the angles. So we have a right triangle. So obviously we have a 90-degree angle. We have 45 and 45. What you're going to notice about this one, what this makes one special is it's actually, if I extend this out, it's just half of a square. And what that tells me is since it's half of a square, on a square, we know all the sides are equal. So I know that this side and this side both have to be the same because all four sides of a square are the equal. And then what that does is leaves us to be able to find this. Okay. So what we're going to use Pythagorean theorem to come up with a little bit of a formula so I can do this kind of on an easy basis. So for right now, I'm just going to call this side x. If you remember Pythagorean theorem, we did a couple sections ago, is going to be the leg squared plus the leg squared will equal the hypotenuse squared. So in this case, it would be a squared plus a squared equals x squared. Well, if I add those two a squareds together, if I have two of something, that becomes 2a squared. Remember, we don't change the power when we do that. We talked about that in previous sections. So I have 2a squared equals x squared. Now, to get rid of this, I'm trying to solve for x, so I'm going to take the square roots of both sides. And remember, the reason why we want to take the square root is it cancels off the squared and makes that x. Well, it also cancels off this a squared and just makes it a. And then we got to take the square root of 2. Well, I don't know the square root of 2, so I'm just going to leave it as a times the square root of 2. And so this hypotenuse, this longer side, can be a square root of 2. So if you know these two sides, it's just that side length times the square root of 2. We don't have to go through and use the Pythagorean theorem every time. Could we? Yes, this is just a quicker way to do it. So let's look at an example of here how to tie this in. So if we know we have a 45, 45, 90 triangle here, and we know right away we're trying to find x and y. Well, if you look at this right away, we know that x has to equal 5 because these two sides are the same. They're the sides of a square. And then the other side, again, we do now have two sides of a right triangle. We could use Pythagorean theorem, but we can just know that if this is 5 and this is 5, then this is going to be 5 times the square root of 2. And that gives me 7.07 if we want to round it, and we could use a decimal value for that to get the length of that side. So a little over 7 for that length. Okay. This next one, again, we're trying to find the side lengths of x and y. What you'll notice about this is right away, we know that x and y have to be equal to each other because, again, they're the sides of the square. But the problem is I don't know either one of those. But now we're going to work backwards. If we know the length of the side, we're just going to take it times the square root of 2 to get to this. So to go backwards, what's the opposite of multiplying by a square root of 2? We're going to divide by a square root of 2. So let's find x first. So I'm going to take that 11.3 and divide it by the square root of 2. That gives me something like 7.99. That's really close to 8. We'll just call that 8. And then remember, the y value has to be the same as the x value. So x is also 8. And I found both of those values very easily. Okay. So go ahead and take a minute here. Figure out x and y in both of these. Go ahead and pause the video. Work those two out. Come back. We'll take a look at it. Okay, so hopefully you had a chance to look at that there. Let's go through and work these again. So again, we're trying to find the value of both x and y. So on this one, I know the value of x has to be the same as that because, again, these both make up that right angle. They're the sides of the square, so x has to be 4. To get the y value, again, I'm just going to multiply just like we did up here times the square root of 2. I can type that in my calculator. 4 times the square root of 2, I get 5.66. So again, without a lot of effort, I was able to find those two sides of the triangle. Okay, this one, kind of the same idea. We know X and Y are both equal to each other, but I don't know either one. But I do know that this is the side of the square times the square root of 2. So I'm going to go backwards and divide by the square root of 2 to get the length of that side. Again, it comes out like 8.98, and we're just going to call that, that's pretty close to 9. And then this one has to be the same. And so without a lot of effort, again, we can find those. And it's just really just based off the Pythagorean theorem is what it is. All right, let's take a look at the next one. So you'll notice on this one, again, we have a special right triangle. Again, it's named off of its sides, 30, 60, 90. So what we're going to do is we're going to take a look at this. The other one was half of a square. On this one, you're going to notice if I extend that out, it's half of an equilateral triangle because this is 60. These two put together would be 60, and that's 60. That's an equilateral triangle. All three angles are same. All three sides are the same. So since all three sides are the same, this is half of that other side. So if I would call this one A, then all the way across or all the way across here would have to be 2A. So the hypotenuse is twice the shorter side, the one across from the 30. Again, let's just call this one X right now. Let's use Pythagorean theorem to figure out what this one would have to be. So again, these two squared would equal that squared. So X squared plus A squared would equal 2A squared. In other words, X squared plus A squared, this would be 2A times 2A, which would be 4A squared. Then I can subtract the A squared over to get the A's together. That leaves me X squared. 4A squared, take away 1A squared is 3A squared. And then just like on the last problem that we did, we're going to take the square root of both sides. So that leaves me X. Again, I know the square root of A squared, but I don't know the square root of 3. So I'm going to call it A square roots of 3. So every time this longer leg is multiplied by the square root of 3, and that's double it. So let's take a look at an example using this. So here, forgot to label these. This is our 30, 60, 90. This one's across from our 30, so that's our shorter side. Remember, the hypotenuse is always twice the shorter side. So if I'm looking for X, all I have to do is take 7 times 2, and it's 14. If I want to find the Y value, it's always times the square root of 3. So I take the shorter leg times the square root of 3. And that comes out to be about 12.12 for that length. Okay. This one, you'll notice a little bit different. Now I have the hypotenuse. So to go backwards, this was double it. So to go backwards, I'm going to take half of that. So I'm going to divide by 2. So to get X, I'm going to take the hypotenuse divided by 2 to get 5. Now that I have the shorter leg is 5, the longer leg is times the square root of 3. So 5 times the square root of 3 is about 8.66. All right. The last one here. Okay, the last one. We have 18 as our longer leg. This time I don't know the hypotenuse or that. So to go backwards, we're going to have to go the opposite of this. So to get X, we're going to have to take and divide by the square root of 3. And if I take 18 divided by the square root of 3, I forgot to grab a calculator here. Let me grab that. If I divide that, that gives me about 10.39. And then remember, to get from the shorter leg to here, I'm going to take that times 2. And that gives me about 20.78. All right, so those are special right triangles. Again, you can do them very quickly. You just have to remember the rules as you do that. To practice these, you're looking at page 375, 7 through 12 all.